showing up. I'm sure by the time I get through all these slides, you'll have KiCad downloaded. It's not that big of a program. Alright, so I'll just go through the objective of the whole workshop, including the first 2 sessions. So, first session we're going to learn how to use the KiCad UI, navigate it, understand all the tools that it offers. And then design a schematic, which I've drawn up here. We don't have to go through the math, that's taken care of. And now we're going to learn how to source the parts for the circuit itself through DigiKey, Mauser. Those are the 2 main Canadian sources. You can use AliExpress, but that's counterfeit parts usually, and they don't always hold true to what the datasheet says. And then in session 2, we're going to actually learn how to design the PCB. That's a bit more of a tricky thing to do compared to doing the schematic. It's a bit more of an art. You'll spend some time doing it, I'm sure. But yeah, we're going to design the PCB, get it ready for fabrication, and then I'll show you the process to ordering a PCB from a manufacturer like PCB or JLC PCB. I'm sure you guys have heard of at least one of those. And then in session 3, that one we don't know exactly when because we need to order the PCBs. But when we do order them, we'll let you guys know through the Discord and other social media platforms, so that you guys can come in and learn how to solder surface mount components and such to the PCB and get it working.
Just that in there, guys. It should be more than a week after your second session that we get all the parts in, and then we'll just put out the schedule that the hackerspace is open, room 2245 on the 2nd floor up here, and it'll be just a drop in whenever you guys are ready. You guys will sign in, tell us your name, and we'll check you off saying you've received your parts. We're going to upload a video on how to solder it all together, and then you guys can go in there, solder it all together, and you can walk away with a nice PCB.
Right on. Yeah. Okay. So the goal for tonight is we're just going to do a schematic. So we're going to learn the KiCad UI. I'm going to guide you through all the different menus. There isn't much. It's actually quite a nice small bit of software. And then we're going to learn how to design a schematic with the KiCad schematic editor. So that includes finding the component symbols in the library that they've got, as well as adding the information, pertinent information to the components. That was loud. Okay. And I'm going to just say a bit about myself. I'm a 3rd year undergraduate electrical engineering student. I'm a lab monitor at the IEEE student branch. And a bit about myself, I'm an electronics hobbyist. I've done a bit of repair, professionally and as a hobby. And I'm also an amateur radio operator. So that is setting up radios and talking with old people. Okay, and then a bit about the experience with circuit design and PCB design. I've done a bit for hobbies, like designing small amplifiers, little transceivers, receivers, and such. Mainly fabricating it myself on a CNC machine, not as much ordering from a PCB manufacturer, but honestly, it would probably be cheaper. Anyway, so that's a bit about myself. And now we'll move on to KiCad. So if you don't have KiCad open already, open up your KiCad. Okay. So when you open up KiCad, you'll be greeted with this nice menu on Mac. If you have the same version, it should be the same kind of layout. Older versions may have a different layout. Should be similar, but maybe a little different, right? So the two programs we're going to be working with is the schematic editor as well as the symbol editor, and I'll kind of guide you through the calculator tools as well, because that's a neat thing. That would be more of a PCB tool, but still handy to have while designing. First steps first, though, we need to create a project. So that would be just up here. We go to File, and under New Project, we click that and select the directory that we want to save it to. And this is where you can have fun, name the project. In this case, we'll name it what the circuit does, which is blink. So blinker. Okay. And with that, we should be greeted with a nice PCB file and schematic file.
All right.
So, the first thing we want to do is we want to open up that schematic file. You could also alternatively hit the schematic editor, that opens it up as well. And now we're greeted with this nice drawing. So I'll let you guys catch up to that. Just a minute here.
Did you have this error?
Okay. So once we enter this this drawing sheet, we can go down to the block here. This is just the information of the circuit, the title, the size of the paper, and the date it was made. And if you double click on the text for title, it'll open up this nice menu. And in it you can set the date that your circuit or your schematic is made. So I'll just hit these three arrows, it bumps the current date into it, so you can set the revision, in this case 1, you can do whatever type of revision standard you want. And the title. This is where you can do whatever you want as well. Blinker, that's what I'll do for mine. And if you have a larger circuit that you're planning on making, you can always change the paper size, the page size. In this case it's A4, so you could technically print this on a normal A4 sheet of paper and it will come out with the same dimensions. We'll keep it at A4 since our circuit isn't too big. Okay.
If you guys need a little slowdown or like a quick review of what just happened, any questions, just throw up your hands and I'm sure you're not the only one with the question, right?
Maybe 0.1% slower.
Okay.
Yeah.
Alright, I'll make sure to go into slow motion.
And can you guys all hear okay in the back? Yeah?
Yeah, okay,
good.
Excuse me.
Yeah.
I was just having I was getting a weird error when I was trying to open it.
KiCad?
Yeah, press it.
Alright, I'm just going to guide you through
So I
the
tried down
sidebar, top bar, and left and right sidebars. Kind of just guiding you through what each option here
Yeah,
does.
website.
So to start, we can set the grid size. That would be the snapping grid. So if you look over here, it snaps to a grid. It's a grid of dots, so it's a little hard to see sometimes. But it's to guide the components, make sure it lines up nice. You can select different your different dimension, your different scales. You can use metric or the two imperial options that they provide, inches and mils. And for those of you who aren't filled in on mils, mils are just 1/1000th of an inch. We'll use metric because we're in Canada.
Michael, we just got a question here.
Yeah.
So he opened it up and it's just like,
What?
yeah, I know, that's what I said.
That's a graphics driver issue.
Sorry?
That's a graphics driver issue.
Graphics driver issue.
Yeah, you gotta do some updates there.
Have you tried turning it
All right,
off?
thank you. Thank you, Ryan. That's my fellow. Okay. Was everyone else able to like set up their page here?
Yeah, how
That's
far,
following along.
How far are we along? Yeah.
Stop here. Okay. Are we good to continue? If anyone needs a hand, just getting up to this point. Don't be shy. Yes.
Take another minute, just because some people are still downloading, it looks like.
Yeah. Okay. Turn on
And then
full
project.
page.
And
The
then
reason I do
I
that
just
is
name
I
it. I
so I can line them up across the page.
And desktop, I guess. We want to save that folder. So, yeah.
Alright.
I just click desktop and then go file again. And then click open project. Yeah. And then double click the bottom one. Yes. Okay. Yep. And then double click title. And name, just name the title like IEEE or whatever.
Okay. All right, we good to continue?
Yeah.
Okay. Cool.
I'll let those guys get sat down. I mean, no one's rushing out of here, right? So, we can take our time. Okay, cool. So for those who just came in, I'll give you the rundown. You open up KiCad, you're greeted with this menu. If you go to File, New Project, you can create a project folder, and once you create that project folder and name it whatever you want, you'll be greeted with this guy here, this menu. You have either your PCB or your schematic, and today we're just focusing on the schematic because PCB is a piece of its own to conquer. When you open up the schematic, we will enter this. It's a nice piece of A4 paper with a title block at the bottom. What we did is we double click on the title and we enter in any information we want. We could change the revision, the blank, the name, which is blinker in this case, and we can also update the date just by hitting that guy. Okay, and once you're done with that, you can hit OK. The information updates. If you have certain symbols or images that you want to put in this block, you can. Up here and there, I think you can also have comments. You can add comments, drawing notes, whatever you want. It's all up to you and what you want to design. Okay, and then I was showing you guys the different menus along the left side menu here. The left side menu is small, it's nice, sweet. We can display the grid dots. I would just say keep these on. It helps you place components evenly and space, right? You can choose different measurement systems, different units of measure. So we can go with inches, mils, or millimeters. In this case, we'll go with millimeters because we're in Canada. This menu here, this little option here, I choose to enable it. It is preference. I have it enabled mainly because when I'm placing a component from this side of the sheet all the way over here to here, and I want to line them up on the same line, it's easier to be able to, have the whole line go across, right? You can switch that on and off too if it gets bothers you. The second one is to toggle the display of hidden pins. So that is on, say, a schematic, you'll have certain pins that are either not connected or just checked off as hidden. This will make them shown or hidden. And then this option here, we will be enabling and disabling once in a while, because this here will make it so that when we place wires, these little guys, they can only go vertical and horizontal. So only in that way, while with it disabled, we can place them in at any angle we want, right?
Can you ever curve them?
No. With schematics, you wouldn't ever want to have a curve.
That makes sense.
That'd be a little curse. But for now, we'll keep it on because we're not doing anything yet. Yeah, now the right hand menus, we have the ability, this guy here allows us to toggle the highlight of nets. So a net would be like, in circuit analysis, we'll have nodes. So this whole line right here would be a single net. And it would be labeled as the 3-volt net, as is standard with KiCad. So it would highlight that, especially for complicated circuits, it's pretty useful because the lines become daunting, and it's essentially the same thing as taking out the piece of paper and highlighting a line with a highlighter. So that is a handy tool that I have not used yet. Okay, and then we've got this guy here. The symbol is an op-amp. This is your symbol menu. This is how you put in, say, the symbol of a resistor, the symbol of a capacitor, etc. And we'll get to that shortly. And then the ground symbol here is your power ports. So that would be your ground symbols here and your voltages there. That is what that is. And then we've got the wires. The wires are self-explanatory. Buses, also kind of self-explanatory. They're just groups of wires. So say if you have an 8-bit bus, that would be 8 wires going through. It makes drawing schematics much nicer. It could also kind of, I think, be represented as a ribbon cable if you're ever doing that. And this is how a wire to a bus. That would be how you split a bus into its elementary wires.
So can you explain just what is a bus again?
So a bus would be, if I have a marker, a bus would be, say I've got a chip that does 4-bit addition or 4-bit subtraction or whatever. It's got a 4-bit parallel output. So that would mean I've got my 4 bits. It would make my drawing very messy if I had these go, wherever all the time, right? Because then we'd have to draw those 4 wires all the time. Instead, when drawing a schematic, it's standard to have what's known as a bus entry point, bus exit point, and just draw a bus, which is essentially just a thicker line. It's a bold line.
Okay.
So in this case, we would have like something like that, and then we would have it go to a much thicker line, and then that would be our new bus, and wherever that takes us throughout our circuit, we can then kind of have it all split off and go to
Okay.
another chip. And then it just makes drawing it much, much nicer. So that's that. We won't need to use it today because, as you can see, there is no 4-bit or 8-bit or anything, any parallel connections. But it is useful to know. Okay. Then we've got a no connection flag. This would mean that if I have, say, a 555 chip and I don't want to have one of the pins connected, I just pop that guy on there, and then when we do the schematic, or not the schematic, the PCB design, it won't try and throw errors when trying to find a connection for it. And it also helps with drawing. It's very useful. A junction, that's self-explanatory. It's a node. It's just where wires come together. We have a net label. So a net label would be if I had, say I had a component going over here, and I wanted to put a label on it. I can label this hi. Okay. So I'll label it a cheesy label. And then say I had a circuit over here. I can add this label over here, and it is no different than the wires being connected. So say I had a circuit, an op-amp outputting voltage over here, and I wanted that voltage to be input over here. So say this is the output of an amplifier and the input of a filter. Over here, this voltage would translate over here, and it would be as if this was connected with a wire. It's good for like organization, making the schematic look nice. Excessive use of it occurs, and not using it could also get messy. You'd have a whole lot of spaghetti on your paper. So that's why we have these. And these are what are known as local labels. So these are only within this sheet, this one piece of paper, this one schematic. So if I had another sheet that had a global label, it would not see these. So as long as you guys understand that, I can move on to global labels, which are a bit more confusing. For those of you familiar with C++, it's no different than global and local variables. So a global label would be one of these. So if I name it hello, that would mean if I had two schematics, two drawings in the same project, and I put this label on another drawing, it would be no different than it being connected across those two drawings. This is good particularly for larger projects or projects where you have multiple different, I like to say, sections of a circuit. So a good, I'd say a good representation of that would be a drawing for a modular synthesizer. That took me a while to figure out. So a modular synthesizer, it's essentially you have different ports, and then you connect them all once you're done building everything else.
So you mentioned if it's like C++, is there hierarchy? So if that global thing was high, it shouldn't matter. 'Cause it's,
I hope it's over. No. What? It is prioritized, I think. I haven't quite tested that. I wouldn't recommend naming this label the same as a local label, but I'm pretty sure it should be okay. It's not really like a hierarchy. It's kind of, it works a different way. Local variables are within the sheet as if it was a variable within a for loop or a function, while the global would be across the whole program or across all of the sheets, across the whole project. So that is how that works. It's a good drawing standard. A lot of people use global for different sheets. So if everyone understands that,
Question.
Yeah.
So the global variable, would that be just for the entire project domain?
yeah, like within the entire project folder. If I was to have over here, to have made, say I make another schematic. I honestly don't feel like doing that. That might add confusion later. But if I was to make another schematic within this project, and in that schematic I had this global variable going to, say, an input of an amplifier, and this comes out of this, say this was a filter, it was leaving the filter going to another amplifier, then that's how we would kind of look at it. And then you just have drawing numbers on each of the drawings, and you'd understand after looking at one drawing, oh, this is where this label goes into, and it's connected. Sometimes you don't need to use those, especially if you have like an A2 piece of paper. It's massive, but you wouldn't want to print those off at Staples, so it's expensive. So A4 paper all the way. Anyway, that's the two labels. I'm not going to go into hierarchical labels. Honestly, I've never used them, and it's not as common to use them. Now you can add a hierarchical sheet. This is the same idea I was talking about, having multiple sheets and then connecting them with labels. And you can pin certain sheets to certain areas to kind of show where they connect. Alright, and then these guys are just the basic stuff. You can delete clicked items with this selected. That means anything I click on will vanish into the abyss. I do not want that selected. You have to hit escape to unselect that. Now you can add a bitmap image. I believe this works with any type of, I'm not going to go through my files, but that works with any type of PNG image, or if you really want a .bmp image. You could add text, self-explanatory. I use that for, say, drawing notes. If I have certain component that I want other people, when reading my schematic, to know, hey, this can be changed out with this, this, and this, or these are options, whatever. Drawing notes, very common in engineering. And then this guy, let's see what he says. Connected graphic lines. Yeah, this is if you want to highlight a section on your circuit and then with the text, I can say, oh, no, that sucks. Okay. There we go. Double click to finalize that box. I could add text up here to say, and then that way I can say anything in this box is part of an amplifier. Right? It kind of helps the readers see which part of the schematic does what. So with that done, I think you guys are familiar. The top bar is all of your zoom, your control. You can print the page, and you can even do the schematic setup. I personally haven't really needed to use a schematic setup, but you can set the default text size, the default line width on the symbols. This is for the rule set, so you can ask the program to go through all these rules and throw errors if there's something that you might have missed. With schematics, you most likely won't miss stuff, but with PCBs, this is a tool that I use very much. You can go through this, mess around. If you screw up, just restart. But yeah, so that is this guy. I never really go through it. I just use the default settings. They work perfectly for me. You can have undo, you can do Control Z, that works. Control A highlights everything, same keyboard shortcuts work through everything. You can find text if that matters. You can refresh the circuit if you made changes remotely and this is still open on the home computer. You can just refresh, update it. Zoom objects. You can show the hierarchy.
So just on the refreshing, so does that mean that this is like cloud based or is like
It isn't cloud-based, but if, say, this applies more if I was to update a symbol. So
okay?
if I would, actually, I'll show you guys quickly. That's a good little bit of an aside here. If I use a symbol editor and I wanted to, say, change a symbol, say I had a resistor that looked a little bit too spiky, or whatever reason. Actually, yeah, let's go with 4,000 logic here. Okay, so say I had this guy, a NOR gate. I can edit the symbol and do whatever I want. Say I wanted that to be the symbol, as ugly as it looks. Once I hit Control S, what it'll do is it'll save it, but it won't update the schematic. Is that this?
Yeah, that's.
Yeah. I thought I had it muted. Because that is the most horrid sound in the world. Okay. Either way, I made it. Say I made a change to that symbol. Once I hit refresh, it'll update it on the sheet.
I see.
Yeah. So again, with the sheet hierarchies, you can look at all the hierarchies here. This shows up when we have a symbol selected. We can rotate it, we can flip it, do whatever we want with it to make it look nice. Up here we have the same options we have in the main project menu. It is just your symbol editor, delete. You can do whatever you want in there. You can browse symbol libraries. So if you had a library of your own with the custom symbols, you can look for them and add them to the project there. And we will get into footprints in the next session, but footprints would be what you see on the PCB. So say a surface mount resistor, that would be how you solder it on, that's the footprint. You can edit those here. Reference designators, so you'll find these a lot on schematics if you guys have read them, seen them, I'm sure you have. That would be something like Q1, Q2, you'd have C1, C2, R1, R2. Those are reference designators. Fancy name for a label. But those are how you differentiate different components, and they help out a lot on the bill of materials, which we'll get into later. But this is the electrical rules check that I was showing you in the schematic preferences. You can run one of these and it will, assuming everything goes well, it'll give you a green, and if not, it'll show you what you are doing wrong. You can do footprint assignment. I've never used it. I manually assign every footprint because I want to be diligent, I guess. I don't want any errors. This is how you screw up a little bit, but it's good to an extent. It makes the job faster, essentially. So it'll give you all the symbols, and then you can go through the footprint menu and assign each. It takes a while to load because it's loading a lot of symbols. I think I made it crash. I honestly, there we go. Okay, cool. So yeah, you'll have all your footprints, and then if you have your symbols, you can assign the footprint. This is useful when using, say, through-hole resistors alongside surface mount resistors, etc. That's how you design your PCB. And then you've got your bulk edit fields. I'll get into that later as well. And then we've got the bill of materials. We can export that to a CSV file. This is how you open up the PCB editor if you don't want to open it up here. And this is for advanced users. Okay. So that's a run through of the menu. I hope I went slow enough for everyone. Okay. I'm guessing everyone's on the same track. We're all able to move ahead.
Let's design the schematic.
Yes. Okay. To get started, I won't start there. I'll start here. This is the schematic we're designing. It is a transistor blinker circuit. You can find it just by searching up transistor blinker circuit online. I added some extra LEDs, of course. I won't go into detail on how it works. I don't really feel like I know what I'm talking about there. But it works. That's the main thing. I have a simulation. If you guys really want to see it, I can show you.
It would be pretty cool to know how the hell the things blink without like a microcontroller.
Yes. It has to do with the capacitors charging and discharging.
Cool.
Now I'll show you the simulation. How about that? I have it somewhere in here. I'm gonna be going through a lot of directories.
We can always show it next class, next week when we're designing the PCB.
I feel like it's more applicable here.
Okay.
There we go. I should have had this link ready. It's using an online circuit simulator, so we'll be able to see. I do have it here. We'll be able to see all of the fun stuff. There we go. Okay. So this is essentially how the circuit works. It is a slow simulation because I have it running at a very slow speed. It's around, it says it right there, 11 hertz, 10 hertz, 9, 8, 7, 6, 5. So it works by charging up this cap and then discharging it through the transistor as this guy is charging up. And then once this guy charges up, this guy locks up and this guy can turn on, and then it discharges through there. I won't go into how BJT transistors work. That is a 351 thing, ENGR 351.
So,
Go for it.
real quick, just to summarize, so the capacitor charges, and while it's charging, it turns off its associated transistor,
Yes.
which also disables the other transistor.
The reason being, the capacitor here generates a negative voltage, which locks up the NPN BJT,
Right.
Preventing any current from flowing. And then that allows this capacitor to charge up, which will then in turn lock up the other one and create an oscillation. And the current to charge the capacitor varies depending on how many current paths are over here. So if I was to add more LEDs, it could speed up or slow down depending on what I do. In this case, that is the schematic. The values are there. I will probably write them down there. That'd be a good idea. I forgot to do that. But yeah, so that's the schematic, the simulation of the schematic.
Can I
Anyway,
put it up on Discord?
Yeah, sure, I can put the link on Discord. If you guys want to play around with it, go for it. Actually, I think I have the thing on my. The lag is insane. It's right here. Okay, there's the link. If it's on the Discord, if you guys aren't on the Discord, the link invite is there.
Or on the Instagram, Roger Believe. You go to that Instagram and you'll be added. And then if I have your Discord name, and you guys fill out the form, I have your Discord name, I can go in there and manually add you to the workshop.
That works too. So yeah, that's that. Let's move on to. I will not have that going in the background. Let's move on to the circuit. Okay. So I'll minimize that. So let's start by adding our first component. This is the dawn of our new circuit. If you go to the op-amp symbol here and click on it, assuming my laptop doesn't die on me, it should open up a menu of all the symbols. I think it crashed. See, so when it crashes, I can show you guys how fast it is. I'm just going to close the program. Okay. So you find your project folder, it crashes. And actually here I should mention too with KiCad, there's this funny thing where the interconnectedness of all the drawings kind of goes out the window if you don't open up the project folder here, or the project file here. If I was to open up just a schematic, it'll only open up the schematic and it won't load the whole thing. Yeah, go for it.
Yeah, do you know in the UI how you can enlarge the circuit components?
You zoom in. Yeah. Well, a lot of the times they have standard sizes, and then you just use whichever size works and shrink the piece of paper if it's a smaller circuit. With this one, I actually think it does fill the page from what I remember. But yeah. Anyway, going back to this, yeah, don't open up. Well, I mean, it's possible you can if you just want to work on the one schematic, but if you need the interconnectedness and you want to be able to bounce between schematics within the software, just open up the blue file. The blue file always works. So I'm going to open that up, go here, open up the schematic editor. Yeah, sure. Okay. There we go. Okay, I'm back. Anyway, round two. Let's see if it actually loads, and if not, I'm going to be sad. It looks like it's loading. I guess this is what I get for getting a $400 laptop. Well, if this doesn't work, maybe eventually. But I think for the PCB design, I might use their laptop as easy. Because this is slow. Okay. So now that we're in this menu, I'm surprised this laptop. You know what it is, Aziz? I think it's because I'm running the streaming to this and streaming to Discord at the same time. The poor laptop here is becoming a space heater. Okay. So if you need a component, you search for it. There's different components. You can even get certain specialty stuff that KiCad has. In this case, we're going to start off with the resistors. We've got a lot of those. So I'm going to search up resistor, and we'll be greeted with a lot of stuff here. So we can get a photoresistor, we can get a potentiometer, dual potentiometer, separate dual potentiometer. We can get all this, and they also have small small symbols, which you don't really need to use unless you're representing a smaller internal component. In this case, I'm going to use the resistor symbol for the American resistor symbol. You can use the European resistor symbol as well. A lot of people think this symbol is sleeker and much nicer, and even I do, but for consistency, I'm going to roll with the US version since we're in North America.
Is that what typically is used in Canada?
Yeah, these are the ones that they use in Canada and the United States. I think there's other places too that use them. The European ones I tend to use for complex impedances, just to show that, especially when I'm doing the math and all that. It's a good way to separate real and imaginary resistances. So when you place it, you get this. And if you click again, it'll reopen this menu. I don't think we need to, because if we need to place multiple resistors, I'm just going to copy that guy, paste it down, and continue that until we have all the resistors I need. If I have the schematic I already know I'm going to build, I know that I need 10 resistors. So just put on down 10 resistors in whatever fashion you want. And you can space them out however you want as well. If you're wanting to have a different snap grid size too, you can go down, right click on the sheet and go down to grid, and you get a little bit of a pop out menu here. You can select the different grid sizes. This is good for fine and coarse snapping to the grid, depending on how you want to design your schematic. Keep it at 1.27 if you want. You can go coarser or finer. I'm just going to keep it at default because that works for me.
So how do we rotate components upon placement? How do we rotate components when we're trying to place them?
So if you want to rotate a component, there's a quick way of doing that, and that is the R key. You can just hit R and it will rotate it around. If you want to flip it, I don't quite know the shortcut. Y. So I'm guessing the other one is X. I wouldn't be surprised. Look at that, it's X. Okay, so if you want to flip it on the Y-axis, you can do that. So that would be N for N, flip it over, or X to rotate it around. That would be more particular, different use.
Michael, I've got a question for you.
Yeah, go for it.
Is it possible to specify dimensions between your components?
I'm not too sure.
Like,
You
does it
can
matter?
do, I mean, it comes down to how you want to draw the schematic. A lot of this stuff is kind of like drafting. It's art mixed with engineering.
The dimensions between components should mostly come down to PCB design versus schematic
Yeah,
design. Right?
If like when you're designing the schematic, as long as everything is laid out nicely and readable, that's all that really matters. If you want it to be like very, very nicely spaced, then that would be the snap grid size. You kind of rely on that. When designing the PCB, there's quite a few tools to actually help you measure the distance between components and nudge them closer to a certain measurement, which is particularly useful if you have components near like a heat source that you want to kind of keep away. So yeah, in this case, I'm kind of spacing things out based on the snap grid and my eyes.
Long story short, right now it doesn't matter. Just make sure,
Yeah.
you just want to space it out a reasonable amount so that the all just work and you can look at it and see what's bothered.
My other quick question, is there a way to make the labels disappear so you can put like resistors close together without the letters overlapping?
Now you'll want to keep those labels. The reason being, the RUS, and I'll actually get into this really quickly here, but I'll show you just now. the R_US label is actually going to be changed out with the value that the resistor is. So if I wanted to say that this is a 10K resistor, and I'd go there, select 10K, and now it shows 10K. And the R question mark is going to be your reference designator, so like R1, R2, R3, so on. But I'll get into that once everyone is done kind of placing all of them down. You guys have everything.
We need a 10?
Yeah, 10.
10.
So 4 on each side and 2 in the middle. Well, I'll get into the hotkeys as well in a second. But I'm going to give a couple of seconds here. Actually, while I'm at it, I'm going to write down the values.
Okay, so Maddie's just going to take a quick picture for edge sock, okay? Is that okay? Everyone off the over and say cheese!
Big smile, everybody. Eric, you're gonna get in it. Come on. Wow. I'll take one quick video. Everybody wave.
Alright, we're going to move on now.
Yes. Okay, so now that we've got our resistors placed down, we won't work on the other components quite yet. I'm just going to show you how to edit the values of each resistor and a quick way of just getting all of them to be the same. Quick as in Control-C, Control-V. So you can enter the properties of the component by hitting right-clicking and pressing properties, or you could just press E. I have a habit of just pressing E as I click on the component, hit E, and it opens right up. It'll have automatically highlighted the reference. You can manually enter in the references, but we will keep it the way it is because we can automatically do that once we have all of our components placed. Manually entering in reference designators is more useful when you already have a circuit and you're making slight changes. So in this case, we have a whole lot of 470 ohm resistors, and then two 22K resistors on the schematic there. So we'll enter in those. So if you have 470 there, hit OK and it updates it right there, 470. Some people use R at the end of a normal, like a kind of to substitute where an SI prefix would be. It just means ohms, no different than if I put down 10K, it'll mean 10,000 ohms or 100,000 ohms, whatever. 470R just means 470 ohms. You can put down 470 or 470R. It's whatever standards you're working with at the time, really.
Question.
Yeah.
Is it possible to create multiple instances of one value, and then when you update one resistor, it updates XYZ number of other instances?
No.
Dang,
Yeah, I know, I wish.
Oh, you see, we put one on each one and actually type in 40 or whatever.
470. Now,
We
if
couldn't
you,
have just created it in the first place and copied that one?
yeah, you could. Like if I already had the information filled out for this resistor and I knew exactly where I want to put it on the document,
Yeah.
and I wanted to just copy all the information over, same as always, I can just copy this over. However, in this case, I can just go here, highlight that one grid, hit Control C, hit OK, and then I can go to the next resistor, hit that again, and paste it. And I can go over here.
I also found that you could just double click on the RUS and then you can update it like
Yeah,
that.
you can also do that as well. You can also individually do that. That works as well. Yes. I go here. I normally do things in bulk, so that's why I go into the properties. But here I'm doing kind of one step at a time. If I wanted to do bulk stuff, I would actually fill out the footprint of the resistor I'm using, as well as the data sheet of the resistor I'm using. And I'd also add in some other boxes. In this properties menu, you can add fields. And normally I would add a DigiKey part number and a DigiKey link field here, so that when I'm going and sourcing parts, I can paste that in here. I would have access to the data sheet. I would have access to the link that I can grab the parts from and buy them. And I would also have the part number if I wanted to create a list and bulk order those parts. In this case, I'm not actually going to go through that. I'll just teach you guys how to source parts. But that's my habits that I've kind of used, and it's helped me a lot, especially with older projects. But here we're just going to do the values, so I'm just going to continue through and kind of just paste all these in. And then the two center resistors here are going to be 22K, so you can 22K and paste that in.
And just heads up, guys, if you guys mess something up, it's not a big deal. At the end, we will post a fully filled out one that you guys can download for next session. In case you messed anything up, forgot to do something, or you got lost along the way and didn't complete it, it's all good. We're gonna upload one, and you guys can use your next session. Or you can use your own if you do it all beautifully.
Yeah, you have the option if you, I would say, to save on time, I'm gonna give everyone the files for next session. The reason being, when doing the PCB, unless you want to deal with all the math and measurements, I would just use the one I provide. Because,
But you can walk us through how you did it.
yeah, I can walk you through. If you guys want to see, I can show you what it would kind of look like, a bit of a sneak peek, while we wait for others to kind of finish this up. Because it's a
Are we
it
just
was,
ordering the known working PCB file?
yeah, we're going to be ordering the one I'm designing here. Because if we were to order everyone's, that would be very expensive, especially on shipping.
Yeah.
So,
But with this knowledge, you guys can always go make one. And in the hackerspace, we do have a PCB printer. So if you're just printing out one, you guys can print it in the hackerspace.
and actually, if you're learning how to CNC a PCB, like engrave the traces onto a piece of copper clapboard, you can design those with KiCad as well. I've done a few. But what I was saying is, you know that shape, the ohm shape? That took me like a good 3 hours to get. KiCad is not friendly to those who want to have nice, intricate shapes on their PCBs.
You're saying it's much easier if you did a rectangle.
Exactly, yeah.
Okay.
And a rectangle is much faster. Not to scare you guys or anything, but this is sort of what it'll look like. And this is what it'll look like. You can enter 3D and actually check out the PCB in 3D. You can even render it, which I will not because my PC will die. Anyway, so that's that. That's a whole other thing. So back to this. I'm going to continue on. I believe everyone's done entering those values. So let's work on the other components. So we've got LEDs, we've got capacitors, we've got two transistors. This is actually quite a small circuit in terms of components. So let's place those down. And I always put down the components first in the general areas and then connect the wires. If you have a more complicated circuit, I would kind of do smaller areas, connect the wires, put down components, connect more wires, all that. In this case, we have a simple circuit. I already have it drawn out, and if you had it drawn out on paper while you're doing the math, you'd already know what it looks like. So throw in all the components, solve one thing, and yeah.
You also teach us how to draw circuits.
Drawing circuits, it's actually the same idea. When you're talking about like drawing it out just on a piece of paper and all that, right?
You know, timing your circuit before you
Right. Okay, so assuming you know, this is a lot of things with engineering. They almost don't teach you the sort of nice blocks that you can work with. I think of electronics as blocks. It's like Legos for grown-ups.
I'm hearing that about everything in engineering nowadays.
Oh, it is, yeah. Because, like, say I wanted to have a filter. This was one of my old last term. It was a project I had last term for one of my courses, where I had 2 filters and then an amplifier. I kind of did everything in a block. I had one op amp doing one thing, right? And then I had another op amp over here. And then I kind of piece it together and then draw it. Now, when drawing a schematic, it comes down to however you want to draw it. Just know the basic symbols, like an LED would be a diode, but you've got the 2 dashes through it. Transistors can be BJT, or you can have your MOSFETs, however you want it. You can have a circle around them. I normally actually don't draw a circle around my transistors. It's preference. I draw it here though because it helps differentiate all the non-straight lines. Especially since we have these lines, it's easier to figure out there. When making a schematic, that comes down to creativity, what you want, and how you do the math. And a lot of the times, just building circuits you find online, whether they work or not, or whether they turn into smoke, doesn't matter. As long as you just have fun, play with them, and take in all the different, things that work.
This is a nice PCB design workshop here. Hopefully in your courses you guys will learn about the actual electronic circuits and everything.
Yeah, I mean,
And
it comes down from experience.
just a reminder, time reminder. 20 minutes left in the session, okay? Let's,
Oh, wow.
Let's keep moving.
Okay. I mean, assuming everyone doesn't have anything to do later tonight, we can want to slow it a little bit.
Let's keep it
Let's keep it on time. Let's keep it on time. So, yeah, it might not have answered your question fully, but when designing circuits is kind of just learning. I find stuff online and I just put it all together. And then, of course, if I calculate stuff using pre-existing circuits I know and combining them and making it do something else, that's a good way of figuring stuff out. So we've got our resistors down. Let's add another component. You can actually enter in this menu by pressing A on the schematic here. I always go to the side and click it. Oh, that is bad. Okay.
At least it's not the SolidWorks error noise.
Oh my god. You got a point there, actually. I should be thankful. Okay, so let's speed through the other components since it is the exact same as the resistors. You just search up, say, a capacitor. If I do capacitor, you don't even have to type in the full thing, and I already found the capacitor. You've got small, you've got large, you've got polarized, you've got a variac. You don't need to worry about those. Condenser. If you guys actually wonder how microphones work, they're little capacitors. Anyway, let's just throw in a normal capacitor. I will rotate it by hitting R, and I'll throw it in here. You can align it however you want. I'm just going to do this and copy it over here, sort of like that. Now, if you guys are annoyed with like how this text is fitting here, you can always select it and move it around. you can hold shift to select multiple and hold shift and control to deselect one thing. And you can drag it around. I'm going to throw it at the bottom here because why not? Gets it out of the way, makes it look nice. Now the capacitors are down, let's let us go on to the LEDs. Actually, you know what? I'm going to place these just a little bit farther down. There we go. Okay, LEDs. Let's enter in this menu, check out LED. And we've got all of these. Now you have, these are LED arrays. We won't be using those. But this first guy here is what we want. And we have the LED. Now we can put those in at the edge of our thing here. Now if time runs out and I don't show you how to source parts in this session, I will definitely show you how to source parts in the next one, as that is quite crucial.
Yeah, we can go through it for all the like for a resistor, capacitor, or something in the next session. I think that's that's what we should do.
Like, I won't go through sourcing parts for all of these,
Yeah.
but I will go through sourcing parts for at least a few of the components. Especially since DigiKey, I'm going to be showing you how to use DigiKey. Mauser works the same way, but DigiKey has extensive filters based on different parts that are available. This mouse sucks. There we go. I wish it didn't stream the audio. I'll have that figured out for next time. So, I don't know where you guys are at. I'm going to put on the transistors as well, just to speed things up a bit. And we're going to be using an NPN BJT transistor. And this is also, actually, I'll probably wait until you guys are ready for this one, because this one's pretty important since we have different options, pinouts. So different pin configurations for each transistor. Some of them are configured differently, and this matters, especially when making the PCB.
Can you make groups?
I believe so. If you highlight it, I believe. Oh, never mind. I'm thinking on the when making a PCB, you can group stuff, but on the schematic, you can't.
Okay.
You can highlight two things though and copy it over if you need to. Okay. While you guys do that, I'm going to pull up a data sheet because that is needed for what I'm going to show you. Okay, so I'm gonna open up this data sheet. I don't know how familiar you guys are with component data sheets, but here is what the surface mount NPN transistor data sheet looks like. I won't go into the details, that'll take ages to explain.
Almost
So,
like they teach courses on it.
do they? They don't even teach you how to make a PCB, this is a technologist's job. So, Yeah, I know, it surprised me. I thought I was gonna learn a lot more than I actually am, but I won't openly say
Did
that.
you just search up the name of whatever it is you were trying to put there?
That depends. Okay, so different parts have different part numbers. If you know the part numbers off your head, then you can search them up and find a certain part.
Let's assume that we want to make something. We definitely don't know the part number off our head. How do we find it? We would just search up what we're looking for and go to DigiKey and hopefully
Yeah,
DigiKey
well-
after you know the part number.
Just to be conservative on time here, but if I wanted an LED, or actually say I wanted a resistor,
Yes.
I would search up resistor, and it gives me this menu. We can get through hole or chip. Through hole is early 2000s, early 1980s, 70s, and late 2000s technology. I use it all the time, but we would want to do surface mount. That is modern and much more compact.
Okay.
So if we are, in this case, we are actually going to do surface mount for the PCB. We get this daunting menu. I'll go through this next session,
Yes.
but just kind of to ease you guys into it, this is how I source parts. This is DigiKey. I search up the component I want, so a resistor, and I sort depending on what the application is. So product status, I want it to be actively produced. Especially if you're making a product that you're going to sell, you'd want to have an active supplier making that component. In this case, we have a resistor, so I can choose a resistance. There is a lot of options. All of them are standardized values based on the E series of preferred values. That is also not taught in engineering. I'm surprised it isn't actually. But that's like all the different values of resistors you can choose from. You can choose a tolerance. Lower the tolerance, more expensive they are. Usually how it is. I go with 1%. 1% resistors are cheap. 5% even cheaper, and so on and so forth. You can choose the power rating for them. So if you're not running much current through them, you can have small resistors. More current, you'd want a larger resistor. You can choose the composition of it, carbon, middle film, whatever. That you'd actually choose that based on the application. Yeah.
So you haven't shown us how to wire it all together.
No, that's what I was saying. I was going to be quick with this. Anyway, that's how we source parts. I'll go into detail with that later though.
Yeah, next minute.
Okay, I'm going to put down the transistors. I hope everyone's got everything else. But right, I was going to show you the data sheet. My bad. I'm all over the place now. Okay, so when you actually choose transistors or any other IC, integrated circuit chip, the little black boxes that you guys see on PCBs, you'd want to find the data sheet for that part, and you want to figure out what that pinout is. In this case, this is our pinout. We've got, let me find it. Okay, I'll have to interpret it from this. Oh, it says it right there. Our pinout is base emitter collector. So base emitter collector, if you guys aren't familiar with an NPN transistor, don't worry. I won't go into it, but I'm sure you guys can find resources online. A base collector emitter or a base emitter collector pinout would be BEC. So when we look at this, we'll look for the BEC transistor. In this case, we've got this symbol here. And when you look at it, you'll notice that on the base, we have 1, on the emitter, we have a 2, and on the collector, we have a 3, which matches this guy. We have collector is a 3, emitter is a 2, and the base is 1. As long as these pinouts match your component, you'll be gold. So we'll add 2 of these guys in, since they're going to be the same. I'm going to rotate it. Actually, no, I won't. Make sure the emitter is facing down. That is, the arrow is facing at the bottom of your sheet. I'm going to flip this so that it lines up this way. And then I'm also going to paste one over here. So I copied it, flipped it, pasted it, that type of thing. Just make sure that arrow is facing down here so that they're going in the right space, in the right place. Okay. So we've got 10 minutes left. I'm gonna run through the wiring, and then I think that'll be all.
Minus 10.
T-minus 10 minutes, yes. I'm almost thinking we might need more time for the PCBs.
Yeah.
Especially if I'm getting questions and going on tangents.
Do I have any objections to extending the next session for 2 hours, just to say 2 hours, but then hopefully it doesn't actually go 2 hours, but it's like, put it to 2 hours?
Because I think,
We're gonna record it all and upload it, too, if you have to leave a little early.
Could also
Would
do some
that-
like pre-watching stuff.
yeah,
No? Okay.
yeah, I don't think anyone wants to do that.
So I think we do it and then everything's uploaded.
Because PCB design, it'll take a bit longer, and it is a bit more challenging. It's a bit of an art, really. So,
You could also have like where like people raise their hand and maybe you come over and help them and answer
Yeah.
their questions, and then you can just keep going.
I think I'll be a little bit more conservative on the number of questions asked.
Oh, somebody's joining me. Somebody's joining this one. You should keep going.
No, we're all good, okay. So now that we've got all our components down, I need to put down the ground and the voltage. Now in this case, on my schematic, I have the 3-volt and ground there, but we're running off a battery. So I won't put those on the schematic. If I did want to put those on the schematic, I would go here, this ground symbol over here, and I would actually search in 3 volts, and I would put in my 3-volt power source, and I would also put in my ground, and throw in ground. Now that you saw there that there's multiple grounds, that's for different ground planes depending on your circuit, especially if it's an RF circuit, a radio circuit, you will have multiple ground planes for different floating voltages. You don't need to worry about that, and in this case we're not actually going to be using these. I just wanted to show you what they are. We're going to be using a battery. So I'm going to delete those. So in this case, we're going to want to use a battery, so I'm going to go back into the symbol menu. I'm going to search up battery. We're using, I think we're using a single cell, if that's what a 2302 lithium battery is.
Yes.
Single cell, so I'm going to put in the single cell symbol. And I realized my circuit is closer to this side of the page. I'm just going to move it over. Okay. So we're using a single cell battery, and this is much easier to work with. We can just line up all of this. Okay, so wiring. That's the fun part. It is very, very fast. We can just go through and connect all of the different points that we want connected based on that schematic there. I will clarify though, that because I know I mentioned to you guys the angled wires. That'll be useful for making these connections here to these capacitors, because I will have this guy here, this guy here, and I'm going to want to connect these up. So how would I do that? I would make, I'm just going to do this here. Okay, I would make angled wires. So I'm going to disable the vertical and horizontal wires. And I'm actually going to put in some nice diagonal wires here. Just like that. So that is how we get that. Oh yeah, that's how we achieve that, that there. And then I turn it back on so that it doesn't look too strange when I do everything else. Wiring it up is kind of however you want. Just don't make it look like a rat's nest and you'll be good. Pretty much.
Any best practices on avoiding that?
Keep lines straight and space them out very nicely. Keep a consistent spacing. And what is this? Okay. Got a strategy.
How did you get those diagonal lines again?
The diagonal lines, I just went here and disabled the horizontal and vertical lines menu.
Are we putting in the values for the best?
Yes, it's the same process as the resistors. You just enter in the value where it's needed.
Micro.
So now with micro SI prefixes with the keyboard, a U is perfectly fine. Micro is the only SI prefix that actually uses a Greek symbol, so we just substitute U and it works just fine. So I just put UF for microfarads. Yeah. So in this case, if we wanted to be consistent, I would actually add in the values for each of the components we added. The LEDs don't particularly need any value, they're just LEDs, or lights. The transistors we're using are 2N3904s. They're a very, very common general purpose transistor. Just like that. I think that's all of them labeled now, I just need to have the wires. Oh yeah, small tip for you guys who don't know. If you just keep on scrolling to the side, the cursor just wraps around. It's super, super nice. You can just go in one direction forever. Just a small tidbit of information that's helpful.
And so those would have to be connected to that like top one. Like they couldn't like you just have like a line that just went from that connected to each resistor, or
Yeah, like okay, so the way I've got it working is this battery is just a lithium cell of 2302 or 2302 battery. So in this case, it's a 3-volt battery. That's why I drew a 3-volt source there. But in this case, it would kind of be more like this. The whole circuit is connected. I hope everyone joined the Discord. Okay. The thing here would be connected to the battery cell like this. Because this whole line is going to be your 3 volts, your power source. And then it's going to drop through. And this guy here would be your ground. Actually, that doesn't need to be there. Another standard, if you guys didn't notice while I was drawing this, any junction will usually have a dot. You don't need those on elbows. It's only when 2 wires go across. The reason there's no dot there is because they're not connected. That's usually how that works. If I wanted these 4 wires to be connected, I would put a dot there. That is not part of our circuit.
Could you also do like a little semicircle over it?
You can, but that's kind of more of a hobbyist type deal. This is usually what you see in the field in the industry. Especially because if you have multiple wires kind of going this way, this way, this way, to have a little jump over, it would kind of be inconsistent. It would get messy eventually. So yeah, but that is one way to do it if you really want to do it that way. We very well could. Okay.
Did everyone get to this?
Yeah, with this, the circuit is pretty much complete. As long as you enter in the values. I can show, for those who aren't tight on time and want to stick around a little bit longer, I can show you guys what the footprints are for PCBs. I'll assign a footprint to one of these guys here. So, actually, let's do a transistor footprint. So footprints are what the component itself, and it's the way it's soldered onto the board. So surface mount footprints get pretty complicated pretty fast.
I think we'll take a quick break. If you want to head out right now, you guys can just head out. And
Yes.
see you next Monday.